So here's L'Hopital's rule. So L'Hopital's rule says, suppose f of a equals g of a equals 0, that f and g are differentiable on an open interval I containing a, and that g prime of x does not equal 0 on I if x does not equal a. Then the limit as x goes to a of f of x over g of x is equal to the limit as x goes to a of f prime of x over g prime of x, assuming the limit on the right-hand side of the equation exists. Okay, let's break this down and put it into English. The point of this is we are going to be looking for this left-handed limit. And we're saying that if you plug in a to the top and the bottom and you get 0 for both of them, that's what this f of a minus g of a being equal to 0 is all about. If that's true, then the limit is the same as if you take the derivative of the top and the derivative of the bottom. Okay, so I want to make it clear this has nothing to do with the quotient rule. We're not taking the derivative of the whole thing. This is something special. We're taking the derivative of the numerator and we're taking the derivative of the denominator. Okay, so let's actually use this to solve the limit we've been talking about. We've been looking at the limit as x goes to 0 of e to the x minus 1 over x. Now, we've shown in our notes before that if we plug in 0 here, we'd have e to the 0 minus 1 over 0, and e to the 0 is 1, so we'd have 1 minus 1, or 0 over 0. So that's the first thing that lets us know we can use L'Hopital's rule. These are differentiable functions, and when we plug in 0, we get 0 over 0. So now what L'Hopital's rule says is that this limit is equal to the limit as x goes to 0, so still the same limit. We take the derivative of the top, so the derivative of e to the x minus 1 is just e to the x. The derivative of 1 is 0, over, now separately we take the derivative of the bottom, which would be 1. So now we just need to look at that limit, and when we plug in 0 there, we just get e to the 0 over 1, or 1 over 1, and so our limit is 1. So here, that's how we use L'Hopital's rule. L'Hopital's rule came in because we got this 0 over 0, and then we were able to take the derivative of the top and the derivative of the bottom, and then we can try substitution again.